Thank you guys for coming. I know it's the last day and people are leaving, so thank you for taking time to come up here. My name is Swetha. I work for IBM. I'm one of the open source contributors there. This is Morgan. I'll let him introduce himself in a second. I previously used to work on a project called Cloud Foundry, and now I work on Hyperledger Fabric. Mostly been focused on a piece, the Fabric EVM integration stuff. So if you have questions about that, definitely reach out to me or find me after this. Love to talk about that. And Morgan.
Hello, I'm Morgan. I work in open source at IBM with Swetha at the same building in San Jose. I came from sort of a container background, maintainer on Docker and parts of Kubernetes, and now I'm doing Fabric, and that's about it for that part.
Yeah, okay. So let's get started. Before I dive straight into Fabric, let's talk about Hyperledger as a foundation. So Hyperledger, the foundation, that's where the Fabric project lies. It is kind of a greenhouse of different blockchain-like frameworks and tools, and we're kind of re-looking at how we want to classify the projects that come under it. There are frameworks up there, so they have different things that make them unique and what you can use them for, and then you have tools for being able to see things like how do you deploy stuff like Cello, or how do you see the blocks. I'm not going to go through all the projects because of time, but there, I believe, 2 more projects that has been added since this graphic was created. And the one we're going to talk about is the first top row, second from the left, Hyperledger Fabric. So as we dive into Fabric, I think the first thing that is very unique, and this is, I think, informative in terms of how Fabric was designed, it would look at business and enterprise use cases. Those are the types of problems we were trying to solve. So Fabric is designed thinking about those use cases. And as you see the design choices that have been made, keep that in mind, right? It's not trying to solve all the problems out there for blockchain. It was being selective of what it was looking for. At the same time, it is flexible. It's not trying to be like only supply chain or only identity. It doesn't have that kind of a focus, but it is focused on trying to build on business relationships and networks that already exist and improving and making those more efficient. So I'll start off with a little bit of an example. Walmart worked with IBM and they created the Food Trust Network. I believe it started to track lettuce here in China, actually. But the whole thing started off because someone in Walmart brought a box of mangoes and said, tell me where these came from. Now, it took them about 3 months, I believe, to figure out all the information, where the mangoes came from, what plot of land, and all of that. Now that information can be done within seconds. And that's a huge improvement in time. Now, why would you care about something like that? One, as trends, people are more interested to figure out where their food is coming from. But in terms of corporations like Walmart and stuff, when you have contamination or E. coli breakouts, it's better to know which set of the produce, where did it come from, so you're very clear about which retailers have that produce, and it's easier to recall and recover from such situations. So it does help in terms of improving the food quality overall and making sure that the good and the best stuff is what is sold. So let's kind of talk about Fabric. Fabric, the first thing that I think is very important to understand, it's permissioned. Now permissioning, it's kind of flexible in terms of what you want to do. So permissioning is very granular. It can go from who's allowed into the network, who's allowed to see data, who's allowed to run a smart contract, who's allowed to read the data from a smart contract. So there's a lot of granularity and a lot of flexibility. And because of that flexibility, and you'll see there's quite a bit of other features here that add to that flexibility and customization, Fabric can be difficult to operate at times because flexibility kind of usually results in some level of complexity. It's highly modular, so there are different pieces or different areas where you can plug in things that you've designed or created yourself. So one of them is the consensus protocol, the underlying protocol. There is an API that you can use, so you can bring your own consensus protocol, or you can choose which one you want. You have different ledger options, membership services, so how you want to deal with identity, and then also endorsement and validation, and we'll talk about that a little bit later. Smart contracts are written in general purpose languages, so there's no specialized smart contract that is being used, or smart contract language that has been created for this purpose. So we support Go, Java, and Node out of the box. If you want, we have, because I work on the Fabric EVM integration, I will plug that in here. But you can plug that in and also get some Solidity contracts if you're interested in that. Privacy has been important to a lot of enterprises and customers, so we do allow features like private data for your chain code, stuff that you want to put off chain. It's all kind of integrated. There is no mining concept in Fabric, and we don't use a token for consensus. So those are two things that are one of the unique things about Fabric. We don't use any of those things. This is different if you've heard about Fab token. Again, that will not be used for consensus. And then the last thing that's very interesting is Fabric goes through this execute, order, validate, which means we execute transactions, then we order the transactions, and then we validate them, which is different from I think most blockchains, which order transactions and then they execute. And with that, let me hand it off to Morgan.
All right, I'm going to try and very quickly go through a high-level overview of how a transaction, high-level overview of the architecture of a Fabric deployment, as well as a high-level flow of the path that the transactions and blocks will take through the network. So here is a basic Fabric architecture diagram. Key things to see are the arrangement of the Hyperledger network, the Fabric network, as the combination of the orderer and the peers, as well as the membership services, which provide the identity to all of these pieces. All of the peers, the orderers, the clients, all have an identity that is a cryptographic identity that can be provided from an external certificate authority, as well as the Fabric CA, which is the Fabric certificate authority that you can run in the network not in the network, but as part of a running network that is provided so that you can have an easier way to manage all of the identities. Let's start with the peer. The peer is is analogous to a node in most other blockchain networks. This is where the actual ledger is. This is the thing that has the blocks. You can query the ledger to get data out of the blocks, as well as the chain code that is executed when you provide a execution request to the network. The peer is where the execution occurs. Separate from the peer, we can see the orderers as a service, which is the consensus mechanism that determines which transactions are going to be considered for blocks and what is the order within the block that the transactions will be ordered in. And then the last piece is, of course, your clients, which interact with the deployed smart contracts on the peer through the SDK. So the client, we provide SDKs in multiple languages to interact with the network, so that your distributed applications can be written in many different languages to provide a nice user experience for the various enterprise people. So Node.js or Node, Go, Python, Java. There are many clients that are different from the set of languages that are supported by the chain code. So again, we have everything basically resolves around the smart contract. That's what executes that is what executes and determines the reads and the writes and the input and output for everything. So that is what your developer is going to write. They're going to write a chain code, and that's what's going to be agreed upon by all the parties. And the developer also writes the client application that uses the SDK to communicate with it. And then what happens is the smart contract interacts with the ledger state. So the actual what is being changed, the get and the put of various basically straight memory addresses is into the ledger. And so we have the combination of the world state, which is sort of an optimization that lets you know what the state of any particular memory value is at the sort of current point in time, as well as the blockchain, which is the accumulation over time of the various transactions, and which are made up of the reads and writes that occur during the execution of the contract. And all of this, there's multiple different kinds of events that come out, which are basically notifications that a new block has occurred, new transactions have occurred, and as well as events built into the transactions themselves, so that during execution of a transaction, you can be notified when a transaction goes down one path to the other during the execution. And so what we have is we have the ledger as a concept, which consists of the blockchain as well as the world state, which is the current values of all of the various changes that have been made. And you can get to the end of the world state by basically rolling forward from the genesis block all the way forward to the final block, and that will be your final world state. Each transaction that is basically consists of reading from the ledger and then writing to the ledger, and that is the basic concept that all Fabric transactions go through. So we record those, and that is what makes up of the transaction that is finally written back. As well in the ledger is the channel configuration. We'll discuss channels in a second, but basically the makeup of the actual who's a member, and the sort of the configuration of the ledger is itself written into the ledger. The world state is optimized for access by using either the key value store or a CouchDB database, which lets you access sort of internals of the transactions if they are structured in a way that faster access can be provided. So we have some time. We're going to go through the definition of a flow of a transaction through the network. And we're going to see three different pieces here. We're going to see the committing peers. These are the ones that contain the ledger. So they have the blocks, and they have they basically write to disk the current state of the world. So basically every peer is a committing peer, in that they all must have the entire blockchain to know what's on it and execute correctly. But only some are necessarily to be endorsing peers, and this depends on the endorsement policy that we can discuss later. And so these are split up basically to allow more scalability, in that you don't necessarily need the same endorsing peers for every transaction, and you don't necessarily need, everybody needs to have the same set of written data. The last type of node is the ordering nodes, and that provides the consensus mechanism to determine which transactions are written to each block and in what order are they written. They don't execute anything. They just get transactions from clients and try to order them into a block. And so, again, everything in Fabric revolves around the endorse, order, validate, or execute, order, validate, where the execution happens, then the ordering happens, and then finally the validation happens at the end. That determines basically which part of the execution and ordering is correct, and finally commits it to the ledger. All right, so here is a network diagram. We can see we have 3 endorsing peers. We can also see we have extra committing peers as P3 and P4 that don't actually execute anything. And we can see the endorsement policy is that the 3 endorsing peers must sign it, and the other peers we don't care about. They're not actually written in the policy. They're just not explicitly mentioned. So the client has to go to each of the endorsing peers and get an endorsement. So what it does is it creates a transaction request and submits that to all of the peers. The peers take that and they execute on it. So they run the smart contract, and during the execution, they collect what smart contract has read and what the smart contract has written. That's the read set and the write set. And those are going to be basically signed by the identities for each peer and returned to the client. The client is going to collect all of these endorsements and package them up into a sort of transaction object. And that includes the read set, the write set, and the endorsement. And then that is going to be submitted to the orderer. As well, other clients might be submitting other transactions for other applications or for other different smart contracts, but they all go to the sort of ordering service. And this will take all of the transactions, package them up, and create a new block, which we see. There's different algorithms to determine what the consensus mechanism is. The sort of basic development environment version is called Solo, and that's just a single node with no fault tolerance whatsoever, but it's intended for development use. There's a Kafka-backed service, which is backed by a separate Kafka service, or instances of Kafka that run outside of the order process itself. And now we have a built-in, from 1.4.1 version of Fabric, the Raft consensus mechanism, which runs in process of the orders and is more scalable, more runnable, more easy to run. So the order creates the new block and distributes it to all of the peers because they all have to have it. The peers take the block and they go through all of the transactions in the block and validate the read sets and the write sets in the block so that none of the changes in the block conflict. So if changes in the block conflict, basically the earlier transaction in the block is the one that's going to be valid, and then the later transaction is going to be marked invalid. And all of these transactions will be written to the ledger, even the invalid ones. So the invalid ones are in the ledger, but they don't affect the world state because they've been marked invalid. Finally, once the committed block has been written, notifications go out, and the client may receive those notifications of new block creation or the events that are emitted during execution of the smart contracts, and then they can act upon those and continue make new transactions. So some more details real quick. We discussed this. We discussed the different ordering services: Solo, Kafka, Raft. The newest one is Raft, and we like to use it, I believe. The key benefit there is not just the built-in and not requiring a separate process, but that the organizations required for the orders can be more distributed, and they're not necessarily a single ordering organization. We didn't really discuss organizations so much, but they can be spread out basically among all of the organizations that are involved in requiring the peers to be endorsing. Quick bit on channels. Basically, channels are a way to shard the ledger into different non-related pieces so that you can enhance the scalability. So if you have transactions that don't have anything to do with each other, you can basically separate those out into separate segments of the ledger and not require them to interact in any way. Quick example of what a channel looks like. So we can see everybody here is on the same channel. They all have the same ledger. They all have the same endorsement policy. They all have the same smart contracts installed. Then if we go to a second multi-channel network, we can see that there's a blue ledger and a red ledger. E1, 2, and 3 have a blue ledger. E0 and E3 have the red ledger. And we can see that E3 has both the red and the blue ledger, and it also has both of the smart contracts on that particular ledger, as well as the blocks for that ledger. And so you can see how the sort of the scalability can be improved. Maybe you only need a certain number of execution environments of peers to endorse because you don't have a lot of traffic on one ledger and you have a lot more on a different ledger, so you can basically either scale that up by adding more peers or figure out a way to split into multiple other ledgers as long as the contracts don't need to interact across the various ledgers, the various channels. And we have a quick bit on endorsement policies. So again, endorsement policy is basically just the requirements for a transaction to be signed as having been executed among different organizations. So when you have different organizations involved in a agreement of a smart contract, you typically want to spread that out among all of the organizations so that they all validate and execute the contract. As part of that, we have, again, chain codes. So basically, even internal bits of Fabric are implemented as chain codes. One of them is the endorsement chain code, and that's the thing that provides the signature of having executed a smart contract. And once it goes through the other side, you can actually change how the validation works as well. So there's the validation chain code, which validates the endorsements generated at the earlier step. But before the ordering is endorsements, and then after the ordering, once it's in blocks, that's the validation step. I think it's time you take over again.
Okay, so what we're going to do now is we're going to switch over, and then I'm going to need your help. People in the back, can you read that? Should I go bigger? Bigger? We good? Okay. So because of time, I'm going to show us a little demo with a sample Fabric network that is running on my, basically on my machine. For time, I have already deployed it. I already have chain code installed, so all we're going to get to do is to interact with it just to kind of show you guys what has been done before. So the first step right here is just using some of our development tools to generate credentials and all the kind of cryptographic material that's needed to start up a network. We're generating the Genesis block, writing the Genesis block, and then we're creating a new channel. The channel is going to be my channel. That's going to come up in a little bit. Then I've just started the network. By the way, this is the FabCar example on Hyperledger, so if you're interested, you can also try this at home. We have, basically, it uses Docker Compose under the hood to create the containers, and what we've done is we've created a network where we have a Fabric peer. This image right here is just like a little container that has been populated with all the credentials that are being used, so that way it's easy for us to interact with the network if needed. Then we have CouchDB, which is the underlying database that is going behind our peer. That was the first container. Then we have a single orderer. It is using Solo. This is meant for development purposes only. Don't use that if you're creating a production use case. And then we have Fabric CA, and this is going to be how we're going to manage our identities and create new identities. And then basically we started it up. You can see that's what this is doing. And then we've joined the channel, so the peer has done that. And then the next thing I did was I went into the CLI, and the first thing I did was install a chain code. I'm calling it FabCar. It's a node chain code, and then I just passed in the path. And then after that, I instantiated it. So we're inside of here. I'm going to open a new tab. I'm going to do this. And you can see before I was showing you all the containers, there is now a different container up here that was not in the output before. And that is the FabCar. That's the container that is running the chain code that I have previously deployed. Now that we've set it all up, I'm going to actually show you, let's start playing with it a little bit. So the first thing I want to do is go through and show you guys the chain code itself. So the JavaScript, we have a new kind of chain code lifecycle model, so it's making this a lot easier, but basically you just have to extend this contract object, and then in your functions you take this context object in, and that will have all the ways you can interact with the ledger. So we have a few functions here. We have init ledger. FabCar is basically like an inventory system of different cars with their owners and some details about them. So we have a function to kind of pre-populate the ledger. Then you can query a specific car, you can create a new car, you can query all of the cars, you can change the car owner, and you can see we have this similar thing where it's context stub.getState, and then for something that is, actually we can look right here. We have a get state here, and then later on when we want to actually write something, we do stub.putState. Just to kind of give you an idea, again, because of time, I'm not going to go too deeply in this, but these resources are online for you, and we will have a link at the end of that, to show you that. So with that, the first thing I want to do is I want to populate the ledger with some information because I don't have it. So we're inside here. This is my CLI container that has all the credentials that I want. First thing, just to show you, there's nothing inside of it. I'm going to specify the name of our chain code or smart contract as FabCar. I'm going to do it on my channel. I'm going to pass in some args here. So first thing is the function. And all I'm going to do is query all cars like that. That function doesn't have any args. Like this. And you can see what I get returned is, that moves it up a little bit, it's all empty right there. Okay. So the next thing I want to do is let's populate that with some information. I'm going to do an invoke here. So now the difference between query and invoke, the peer doesn't really know the difference between that. This is a client-facing thing. The client knows the difference between the two. And if we're doing a invoke, basically what we're saying is the client needs to go and collect all the endorsements, right? Versus a query, we don't really care about submitting this as a transaction, so we just want to get the result based on whatever is the current state. And thank you. So that's invoke. I'm going to do this, but I'm going to actually do init ledger. Run that through. It's successful. And just to show, let's see what the data is. Now we have a bunch of cars in there. Now, typically, though, we want to use something a little more user-friendly than the CLI to interact with, the Fabric network. So I'm going to exit out of the container here, and I'm going to show you some of our SDK. So I'm going to be using the Node SDK. All of these are using features of Fabric 1.4. This is a new chain code lifecycle. It's exciting. It's kind of there to kind of make things smart contract development easier, as well as application development a lot easier. So going into FabCar, the first thing I'm going to do is, I'm going to show you guys what's in the wallet. Nothing is in the wallet. So in a typical scenario, you would need an admin to be able to create new credentials. So the first thing I'm going to do is enroll as the admin. That's going to be second. And just to show you guys what is happening, we're using the Fabric CA client here, and then we're using the wallet coming from the Fabric network modules. We connect to that CA.example. I showed you guys there was a Fabric CA container before. And then from there, it's just doing a check to see if admin has already been created. If not, it's going to go enroll ourselves as the admin. So if I show you guys now, there's an admin directory, and then I can go even more, and we have public and private keys. Now that we have this, we can create a new user, because typically the admin is not going to be the one running all the transactions. You would actually need a user, so I'm going to register a user. Oh, okay. Well, this is going, I ran this demo once already, so this is what this problem is. Place 2. Let's see if that works. I don't think that one runs. Okay, so I'm going to show you guys user 1, even though, because I haven't changed all of them, that's a new set of public and private key. And the reason is because I've already done this demo once, and the user one ID in the Fabric CA has already been used. So it's like, hey, somebody already registered on this name. You can't use it now. So even though it says user one, you saw me change the code to user two, and that's what's actually happening under the hood. Next thing is let's go into query. Similar kind of structure in terms of code, but we no longer need the Fabric CA. We just need the wallet, and we need a gateway. The gateway is how we connect into the Fabric network. So it's looking for the wallet. What we're going to do is we're going to check for user two. We're going to connect to user two. And we're just going to query all the cars. Oh, whoops. Because the folder is user one. Okay, now I have messed this up. 1 second. There you go. A long-winded way to say this data is the same kind of data that we had earlier on. Now, because of time, I'm not going to go through too much more, but we do have an invoke. Very similar kind of code here from previous, and the only real difference here is here we use submit transaction, and then the other code we have is query. So on the right here that I'm scrolling through is the query code, and this is on the invoke. And kind of, you'll see that the code looks very similar to each other. And then this is really the key difference here. Here I'm evaluating, and then here I'm submitting. And again, this is a way to tell the SDK, I want to submit this transaction, get all the endorsements and things like that. With that, I'm going to quickly get back to our slides. Don't have too much left, and we will be taking questions in just a minute. So the first thing is just our roadmap. We went 1.0 almost 2 years ago. Channel selective, this is very different from the old version of Fabric. And now we're working towards the goal of getting 2.0 out, which should be coming out hopefully soon. 1.4 is an important release for us. That was our first long-term support release. With that, we have a change in the chain codes, life cycle, some of the stuff that I was showing today. The Bauer EVM is now something you can kind of plug into the Fabric network. So because I work on that, I'm going to mention that. 1.4.1, what's cool about that is we added Raft as an option. So if you're interested in that, also come find me and I can introduce you to some people. And then the cool thing with 2.0 is there are different changes. One of them is the Fab token, which will be using a UTXO model, so it'll be a little bit different. But that will be there. RAF will become a default, and hopefully there will be a migration path from Kafka to Raft. So those are kind of quick things I wanted to mention. If you're getting started with Fabric, there are quite a few tutorials on the Hyperledger docs. This last one, FabCar, is the one that we just did, or the one I just showed. These slides are also online, so if you don't get a picture now, there is one there. Why does IBM work on this? We do offer an IBM blockchain platform as a service on our cloud. And then the underlying thing is Fabric, and we kind of put some layers on top of it. Some resources, the Hyperledger docs and tutorials are the first link. As part of IBM, we do create a lot of code patterns and lectures, and these are all kind of free for you guys to access and use. We have them there for you guys to learn about a lot of open source technologies, not just blockchain, so go ahead, check that out. And then we have some links to get you guys started on the IBM blockchain platform if interested. If you're interested in contributing to Hyperledger, we always are welcoming new contributors, new ideas. We would love that. There is a China working group for those of you who are based in this part of the country, and to my knowledge, very active working group. So take a look at that. Come to one of our events. And thank you. And I think we have time for no questions, but if you find us afterward, we will answer them. Thank you.